welcome to this full presentation of SigmaPlot 15. Thank you for the kind introduction. Just a few things about me. My name is Sebastian Wassenberg, and I'm a data scientist since 2012. I work as a data scientist since then. And so I know how to analyze data. It's not always that fun, so much fun, but we need to get more insights into our data. And one thing is to visualize them first, and of course to analyze them. And I'm not a developer of SigmaPlot. I'm just an ordinary user, maybe just like you. So I can tell from experience what I like and what I don't like, what I miss and what I like about this program. First, some words about SigmaPlot 15. It's called, of course, SigmaPlot. So you might think, oh, okay, that's a nice software solution to get nice graphs or something like this. Yes, of course, that's why the name. But you can also run data analysis. You can also compute many statistical analysis that you might find elsewhere in a specific program for this kind of analysis. But many statistical programs don't have the data visualization capabilities that SigmaPlot has. And you have both in SigmaPlot 15. There were once two software solutions for this for these topics, but now you have both in SigmaPlot 15. So it's a great tool to not only visualize your results, but also to analyze them. So you can tell, there's a significant difference somewhere, or I have a significant association between something or whatever. And one benefit of SigmaPlot is that you get publication-ready graphs. So you don't have to copy and paste something in your Word manuscript or something, and then the journal will tell you, okay, I want this graph as a single file, and I want it as a TIFF file or EPS or whatever. And then maybe you think, okay, what is this, and how do I get from, for example, Excel to a TIFF file? Usually there is no way from Excel to a TIFF file. But you get there with SigmaPlot, and very easily. And yeah, these are my favorites about SigmaPlot. You have guided dialogues, very nice, especially when it comes to the field of statistics. It's not something that many of us are familiar with or have some struggles with it, of course. There we have some guides. When you are asked what you want to compare and how many treatments do you have, and so on and so on. I will show you in a minute. And you have the same kind of guided dialogues for graphs as well, because there are many graphs out there in the world, and you use them for specific purposes. There is no graph for everything. There's one graph for everything, yes, but it's not the one graph that you can use in every situation. You have to pick the right one. And another thing, we have a flexible data input. That might be sometimes overwhelming because you can enter the data in very different formats, meaning you can put the raw data in, you can put summary data in. I will show you this also. And sometimes you mix them up or something. That might be a little challenging, but it's great that we have this flexibility, because sometimes you don't have the raw data. If you, for example, have data from another paper or papers that you want to combine, maybe you want to run some kind of meta analysis or something like this, or you want just to combine them in another analysis, you can do so with SigmaPlot. And when it comes to graphs, you can adjust almost everything, and that's very great. For example, some things I missed in other programs, in things like adding a break to an axis. It's something you want to do sometimes, but it's very hard to do in many programs. There's no option for this. Here in SigmaPlot, we have a checkbox for this, and just check it and you're done. The same with box plots. Maybe you're familiar with box plots. They show the mean and the first and the third quartile of your data. And sometimes you want to add the mean to a box plot as well. It's not an original box plot. The inventor of box plots doesn't want it to have the mean inside this plot. But of course, you can add the mean with a single line. And there's also a checkbox for this in SigmaPlot. It's something you can't do in other grader statistic programs. There's no option. And you can arrange multiple plots, multiple graphs on one page. So you find something like you saw in a paper where they have one figure called figure 1, and then they have 4 figures in there, figure 1a, b, c, d, and so on. You can do this with SigmaPlot as well, that you can create a graph, figure 1, with subgraphs, for example. And you can run statistical analysis. I just told you that we have a flexible data input, for example, on summary statistics, which is sometimes very nice. So just get our hands on SigmaPlot. And first, I want to, the other direction, there we go, show you a little example. And first, of course, SigmaPlot. Version 15 it is, and it looks a bit more, it's adjusted the look and feel to look like the Windows 10 version look and feel, like this bar here, up there, and so on. I don't use Windows 11, so if you ask, okay, how does it look on Windows 11? I can't tell you. I don't know this, but it looks very great on Windows 10. And when you open SigmaPlot, you will get this quick start guide. And it will be, the first setting will be the Open Notebook tab. That's maybe not so interesting. The Create Graph tab is something I want to show you, because I already mentioned that we have flexible data input, and we can create, as you can see, very different graphs. Some graphs are very specific for specific fields, like these kind of graphs here is more something in chemistry. It's not something that you use in, for example, psychology or something. You will never see these kind of graphs there. Or these vector graphs, you will also never see them in psychology or medicine. You will find them more in biological or geological data and so on. And yeah, we have many different options. So there are many different ways to enter our data. And that might be confusing at first. So I can only tell you, explore this menu here, because you can choose a specific kind of graph. You get this little preview here, and you get a little preview how to enter your data, how the program expects you to enter the data that you want to plot, you want to visualize with a graph, or that you want to analyze with SigmaPlot as well. And that's very helpful, because depending on the graph you want to create, or depending on the analysis you want to run, you might need to enter the data in a different way than you maybe are used to. And that's something very normal, because every statistic program expects you to enter the data in a specific way. So it's not something like a bug or so for SigmaPlot. It's something that's very common. And that's the kind or the way to enter the data, something we need to know before we enter data. So we can, for example, if we want to create a bar chart, a simple bar plot, and we see, okay, I need a y and an x value, y for, of course, the y-axis and x for the x-axis, and so on. Or when I want to create something with error bars, then I have the value I want to plot with the bar, and then I have the error bar, which is represented with some value, and I need a column for this as well. For example, when I want to enter this data in my worksheet, so I already have the thing just for now, I want to represent by the error bar. And I can also tell a program, no, I don't have it. I have raw data and I want it to be the row mean, or I want it to be the color mean, and so on. You have very much options here. And that's why it's very helpful that the developers integrated this preview, this graph preview, how you enter your data. You find it everywhere in SigmaPlot because you have just so much options. Okay, for now I want to skip it. And I prepared a little demo. Just, yeah, it's a fictionary example here and not a real one. Just a little background story here. We want to compare two drugs, just called drug A and B, regarding a virus infection. Maybe you think of some kind of virus, and we have here CT values. And we want to compare these two treatments. Is treatment A maybe better to fight back this virus than B, or it's the other way around? Usually higher CT values represent lower viral load, so higher values are better than smaller values. Yeah, of course, we can first visualize this data. And when we have CT values, something that is measured on an interval scale, so we can compute the mean and the standard deviation, then we might tend to visualize them, the mean and the standard deviation. And therefore, we can use a bar chart. Here you find in SigmaPlot the tab create graph, and there you find the same options we saw in the quick start menu. And I can go here to bar, and I want to have a bar chart with error bars. You see there every direction is possible, of whether vertical or horizontal. You can create it in many ways. I stick to the vertical option. And here you see again a little preview. And then you can check, okay, is this the format I entered my data, a Y and error? No. So, worksheet columns, no, that's not the correct input. I don't have the values I want to plot in my worksheet columns. I don't have the mean here. I don't have the error, the value for the error bar. I don't have it. I have the raw data. So let's have a look. And here I can select many different options. In my case, I have the values for group A in one column and the values for group B in another one. So I want to compute the column means. And here you see the symbol value is the mean of the column. Very nice, very informative. And you see, okay, that's the mean. That's the mathematical symbol for the mean. And the sigma is the symbol for the standard deviation. And the standard deviation will be our error bar. You see it here again. Error calculation, standard deviation. You could change it to something else, to standard deviation, standard error, whatever you want. Usually it's the standard deviation and should be the standard deviation from my point of view. Okay, next. We need to choose our data format. And here again, we have this little preview, and the question is, how is your data organized? Do you have at least one Y column and X data are assumed? Yes, because I don't have a specific X value. The X value would be drug A or B. So the columns are my X values, and that's what is mean here. the X data are assumed. If you have a specific column here for your X values, yeah, you could choose X and many Y. But I don't have it, so it's many Y. And again, I just can tell you, when you're new to the program, have a look at these previews. They are very helpful. And of course, if you learn a new program, you will need some time to get familiar with it. It's the same with every program, especially when you have a lot of options. But they make it very, very, I can't tell you how it could be made different when you have so much options that you give them the preview, how it is organized. Very helpful. Still, you have a lot of options, but you see what is expected. And you can compare this, what is expected, with the way you entered your data. And then you might know, okay, I have to rearrange it, or you know, okay, I select a different format, and that's the one I have. Then you're good to go. Okay, I choose menu Y. Click on next, and now I have to select my columns, and I can do so again. It's here a little preview. I can go over the column heading, column title, then the pointer will change, and then I just click it, and that's set 1, and then let's ask for set 2. Okay, that is this one, and maybe I have a third one, a fourth one, and so on. Then I could enter them in the same way. I don't have it, so I click on finish. I'm done for now. And there is my graph. So I make it a little bigger. I zoom a little bit in. And maybe you think, okay, he told me that we have nice graphs and so on. And you might think, boring gray columns here. That's not so nice. Of course, the default setting of a graphic or any graphic program is usually not that very nice. It's just very, very clean. And we can adjust everything in here. You can do so by going over each element. Then you have this little bar here, dialog, where you can change specific things regarding or depending on the element you clicked on. I personally don't like this thing. I like when you have the options in one window, and we can get there when we go to the Home tab, and there's an option called Graph Properties. And when you click on this, then we have this little window. And there, for example, I can change the lines. The lines, meaning here the borders. I don't like borders, especially not for the Y axis. Always think about here the axis you choose, X data, Y data, then you can adjust everything for the specific axis. I don't want the Y axis on the right, and I don't want it on the left. Of course, when you don't have any Y axis, you don't have anything here, any ticks, so on. So I have to leave it there, but I don't want this black line. So I just say color is none, and then I have no line there. The x-axis as well, I don't want it on the top. Just get rid of it. So I'm going back to I go back to the y-axis because I don't have these borders anymore, but maybe I want to have grid lines for the y-axis. And here, when you click on y, then you might think nothing is happening. Yeah, it isn't, because you have to select the style for the line properties, and the style right now is none. So we have no grid lines anywhere. And here again, I can select very different options, solid line, dotted line, and so on. I want a solid line. And here you can adjust the thickness of the line, you can adjust the color, transparency, where it is in the plot, if it is below, for example, these below the bars or above them. You can change it as well if you need to. I like this version of the graph much better. Now I just want to get rid of the tick, these little darker things here, this major ticks. And here again, can choose from the axis major ticks. And I can select, for example, no, I don't want to have them. When I have grid lines, then I don't need the ticks anymore because it's the same height, so I don't need them. And maybe you also want to change something else. For example, you want to add a break somewhere. Maybe you see, okay, the scaling is now from 0 to 140. Why is this? I want to change it. Of course, scaling, you can change it, but you can enter here, okay, I want it to 70. And then maybe you want to change the ticks. So here we have every 20, we have this ticks, and maybe you want to change it, then you can do so right here, usually. Don't know why I can't enter it now, right now. But one other thing you might want to have, you see the difference is very small between the CT values for our drag A and B. Maybe we can enhance this plot a little bit. So maybe we just start with 20. You could tell the program, okay, doesn't want to start from 0. I want to start from 20, of course. It's something you should avoid because every scientific plot should start, the y-axis for a scientific plot should start at 0. Otherwise, effects might tend to look a little bit larger than they are in reality. If you want to zoom in this area, you might think about adding a break to your y-axis, and you can do so. Yeah, I told you already, with one click, show a break, and you can enter here the values, for example, from 5 to, let's say, 25. Because you might think, ooh, it looks ugly. Yeah, it does. Because you have to change it. You can change the position of the break. The default position is half of your y-axis. And you can enter here a value. When I enter 50, it means it's the half, 50% of your y-axis. There is the break. And if I want to have it a little bit lower, then I tell the program, okay, 20 there, or even a little bit below this. And the gap width is 5 millimeters right now. We can change this as well, for example, to just 2. So we see a little bit more. And you can also adjust the interval. It's now splitted. We don't see it here because it's so small. But you have one interval for the post-break interval section and one interval here for the below break or pre-break interval section, and you can change it as well. I will leave it right as it is for now. Just wanted to show you how you get a break here very easily. And we see again, okay, there might not be a difference between those two drugs. And of course, something you might want to change is the color. You have some presets here. You have some custom color templates that you might want to use. I go for, let's say, Carnival. Nice colors. Yeah, you can change here everything as well. The color of the edges, for example. I don't like them because if you have a fill color, why do you need a black line around it? It's of no use. It might something that will just get pixelated or something. Just get rid of it. And when you do so, I got rid of it by setting the color to none. Then you might think, oh, now I lost my error bars. Luckily, we have a setting for this as well, a specific setting for the error bars. When we change the line color, yes, it also affects the line color of the error bar because it is also a line, but we can set the color of the error bars on its own. So I just said, okay, it's black, and there we go. Very nice feature here as well is that you can very easily change the direction of your error bars from 0 away from 0 like it is here, or in both directions, maybe something like this. Or you can also say, okay, it goes up and down depending what you have, positive, negative, and so on. Away from 0 would mean that when you have negative values, then the error bar would go down. And you have also the option to set the direction in your worksheet. It's not something I want to show you today, but just something I want to mention because you have all the options. And here again, you have the measure that you want to represent by your error bar. You can change it here as well. If you might end up with a graph where you say, oh, I choose the wrong or the wrong measure, then you can address it here as well and change it again. Also here the color means. Okay, so that should be all for this graph. And now that we plotted these data, we might want to analyze them. We might want to have a look at it and see, oh, they are very, very similar, the means here. But we want to tell if there is a significant difference or not. You can't use graphs alone to tell if something is statistically significant or not. You need statistical tests for this purpose. And we have them in SigmaPlot. We have this Analyze tab. And there we find all the tests we need in this drop-down menu. Very, very much, very much options. You have all, of course, not all the tests you find in statistics. The field of statistics is very, 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 very large. So you don't have every single statistical test here in SigmaPlot, but you have the test that you use the most. And from the test you use the most, you have all. That's that I can tell you. And when we want to compare the means, for example, we want to use a t-test. But maybe you don't know this yet. You don't know, okay, I have two groups that I want to compare regarding the mean. What test should I use? And therefore, we have an advisor here. Just have a look at this. The advisor wizard will ask you some questions. For example, want you describe your data? Do you want to predict a trend or something else? Or compare groups or treatments for significant difference? Yes, that's what we want to do. Then we ask, okay, how are the data measured? By numeric values like CT values, or do you just have a rank so you know, okay, some person has a lower value, the other one has a higher value? That would be meant by order or rank. But we have the exact value, so we have numeric values. Did you apply more than one treatment per subject? No. The subjects that either get drug A or B, they don't get both. So no. And then we are asked how many groups or treatments we want to compare. We have two, A and B. And I click on finish, and now, ta-da! I have my suggestion. It's a t-test. Okay, so I don't have to select it here from the drop-down menu. I just can click on Run and select my data for the t-test. And here again, like with plots, For some tests, not for all, you have the option to enter the data in a specific format or in different formats. For example, you can always enter the raw data if you have them, or for example, you have the mean, the sample size or the standard deviation for each group that you want to compare, and it would be enough as well for a t-test. Here we have the raw data, and again, we have this preview here, and if I change to index, you see, oh, that's what you what the program would expect when you selected index data format. So you have an index column, a column that will tell you, okay, which person belongs to which group. We don't have it, we have the raw data. Each group is represented in its own column. So I select raw again, click on next, and yeah, if I selected one here, it's already selected here in the selected columns field. I select first one as A, the second one is B, and I click on finish. And now I get this information: normality test failed. Do you want to run the Mann-Whitney rank sum test? No, not for now. I will stick to my t-test. And there we get the test report. You get you get all the information you need for a paper or for a manuscript to report the values, the results you have. I wouldn't recommend to just copy and paste this section. That's not what you report, but it's very helpful to have a starting point where you have all the numbers that you need to report. In what way you want to report them is your decision, but you have all the numbers and you have the p-value here, and you have a nice narrative result. So what does it mean, p equals 1? Here you know the difference in the mean values of the two groups is not great enough to reject the possibility that the difference is due to random sampling variability. There is no statistically significant difference between these two groups. That's what a p-value above 5%, above 0.05 would mean. If it's below 0.05, then you would tell that there is a statistically significant difference, but there isn't because we have a p-value of 1. And here we have the exact means, 29.8 for the one group and 29.8 for the other group. So yeah, no difference. And with these results and with this graph, you might say, yeah, it doesn't matter what we use, either A or B, it doesn't matter. They both get the same results. We get the same mean CT values. We got the information that the assumption for normality. Most statistical tests have one or many assumptions. A very common assumption for parametric tests is the assumption of normal distributed data. And therefore we have a test, and we see here this test failed. So we can't assume that our data follows a normal distribution. And if you have this case, you usually shouldn't use a t-test anymore, because a t-test assumes that your data is normally distributed. And if it isn't, you should use a test that doesn't have this assumption. I just rerun this t-test because then I get the same note here. Do you want to run a Mann-Whitney rank sum test? Yes, I want to do it because the SigmaPlot will check the assumptions for you and will give you this hint. It's very helpful because if it doesn't, you may not ever notice that there are assumptions for your tests. So it's great that we have it here. Just click on yes. And now we see the results of our Mann-Whitney rank sum test. The Mann-Whitney test doesn't compare the means. What is compared is are the ranks, and the ranks are something similar to the mean, the median, sorry, not the mean, the median, and the 25 or 25 and 75th percentile, or first and third quartile. And here we see there is a difference. The median is 20 for drug A and 30 for drug B. And now we have here a p-value below 0.05. And now, yeah, we have a statistically significant difference. You see here, the difference in the median values between two groups is greater than would be expected by chance. So it's not just the chance what we found here, there might be something else going on. There might be a difference, or there is a significant difference between those two groups. So why do we get a different result here? It's the same data set. It doesn't change. It didn't change anything. Why this different result? Maybe we should create another plot. When you run something called like a non-parametric test, and the Mann-Whitney test is a non-parametric test, you might want to use a different graph. You don't want to use a bar plot anymore, because these tests don't compare the mean, they compare the median, not exactly, but you can think of it like it is a comparison of the median. And therefore I get back to create graph and go to box, because box plot is the way to go when you want to have when you have a non-parametric test and want to visualize the results of this test. Again, I choose the same data format, menu Y. I select A and B, click on finish, and now this graph is plotted on the same page as the one before, and they overlap. That's ugly. Just go to graph page, and there we have option arrange graphs. Yeah, I want to have the landscape mode here, 2 graphs side by side. Click on apply, and there you go. And of course, I could adjust this graph in the same way as I did with this one. I will leave it for the time being. I just want to show you that these graphs look very different. You have the same data, but very different graphs, because here we have the median. The median is inside these box plots, and you can't see it because it's we have this outlier so far away. That's why I will reduce the scale to 40. Now you see it. Box plots, we have this box. Inside the box, somewhere inside the box, we have a line that is the median, and the upper end of the box is the third quartile, or the 75th percentile, and the upper line here, and the lower end, sorry, the lower end of the box, that is the 25th percentile, or the first quartile. And we have these whiskers here. They represent the minimum value and the maximum value that we have. And now we see, when we compare the median, we have we have a difference here, because all of the CT values for our drug B are higher than the values for drug A. We only have one value for drug A that is very, 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 very high, and that's why I go back to end of 140. This one with 120. One value is much higher than all the others, but the others are smaller. And that's why the non-parametric test would be the better one. Better meaning it's more appropriate for our data set we have than to compare the means. So that's what I wanted to tell you, because the mean is always affected by very large or very small values that you have, and that's why you might want to create both plots. If you don't know how to get more information about your data in another way, there might be other ways, but plots are always great to get a feeling about your data, to learn more about your data, and of course, to use this in your presentation or in your paper or whatever. How to use this in your paper? We have, of course, here under Home, the option Graph, and then you can go on Export. And I just want to export it just to show you that it's very easy. Here again, when you use Save As type, you can select, for example, TIFF format or EPS or PDF or these nice graphs you see on the web every day. It's SVG, for example. It's a very nice format because it's only text, and that's why very, very nice for a web. And you can export it as a PDF as well. But when you choose PDF, be aware. No, that was something that changed. You have this PDF vector option in 15. Before the version 15, there was a difference between PDF vector and PDF pixel-based format. You should avoid, when you want to have a sharp, crisp plot on every screen, you should avoid pixel-based image formats. You should always go for vector-based formats, and that's why PDF vector is great, SVG is great, EPS as well is also vector-based, very nice. I will just choose PDF vector, save it. I have to give it a name. And here again, you can choose the DPI as something that you might be asked from a journal. Okay, I need this graph, but I need it in a higher resolution. DPI is the resolution of the graph. For print purposes, you only need 72, a low value, because there you don't see this difference anymore. But since we have everything digital nowadays, you should go for a higher DPI, because if someone reads your paper on a Retina display or OLED display or something like this, they have a very high resolution. And if you have a low resolution graph, it will get pixelated and doesn't look nice anymore. So go for a higher value. 300 is most times the appropriate value. And I can show you first what a graph will look like. Okay, it opened somewhere. Now we have it. And it's for this graph I selected. Yeah, vector-based means I can zoom in as much as I want, and it don't get pixelated, and that's something you should go for. Okay, and here that's the message you should take away from this little exercise. Choose the adequate statistics and the adequate plot for your data, because if you just plot the mean with the error bar, you might hide something, or something might be hidden in your data. You might not intentionally want to hide something. That's why it's this little plot from Alison Hurst, that your summary statistic might hide something. Maybe you have the same mean when all the values are around the mean, but it doesn't have to be. You get the same mean when half of the values are very high and half of them are very low. You get the same mean. You don't see it. So that's why a box plot might be a better way to represent your data. And of course, there are more options as well, that you can run ANOVA on summary statistics. or that you can recreate some more advanced or fancy plots. And I just want to show you this. A plot you can use for example, results of a binary logistic regression. It's something that you will come across in medicine very often because you then get an odds ratio. And odds ratios are very common used to tell you, okay, if you do this and that, then the probability for a specific event will increase or will decrease. For example, do more exercise, then your cardiovascular system will increase. If you do less, it will decrease. And sometimes you can tell, okay, 2 hours more, then there's an increase in like 5% or something. That's something you can communicate with an odds ratio. And here's a nice study from this year. I like it because it's for educational purposes only. It's not something I made up myself. It's a published paper about the the COVID-19 risk depending on the consumption of some alcoholic beverages. And here we have the plot, this one, with the results of a logistic regression. And I just want to focus on the red wine drinkers. That's why I make it a little bit smaller. We have these values. We have the non-drinkers compared to red wine drinkers, 1 and 2 glasses, or people that drink red wine, 1 and 2 glasses of red wine per week. So, and they have an odds ratio of 0.88. That means that the risk for COVID-19 infection, the probability for a COVID-19 infection, is only 0.88 times the risk or the probability of persons that don't drink red wine. So that would mean that the risk for a COVID-19 infection is lower when you drink at least 1 and 2 glasses red wine per week. And you see the value gets even lower the more you drink. Wow, very great. Now, and finally, a scientific proof to start day drinking. Yeah. Maybe, but you should stick to red wine according to the study. If you drink a lot of beer, and if you start day drinking with beer or cider, that might not be that good because we have values above 1. And in terms of an odds ratio, that would mean that the risk for COVID-19 infection will increase with an increased consumption of beer and cider. Of course, you should think about that not the alcohol itself is the reason why the risk is here higher and the risk is here lower. You might think of the situation where you drink more red wine and where you drink more beer. Usually you drink more beer when it's more crowded on festivals or whatever. I don't think that someone will drink red wine on a festival. At least if it's not a wine festival or something like this, then it might be different. But maybe red wine you drink maybe with the special person, and maybe with this special person you drink a lot of red wine, but you just don't have so much contact, and that's why the risk might be lower for this kind, for this subgroup of alcoholics, I call them now. Yeah, and maybe you want to recreate this graph. It looks very nice, and I will show you how you can do this with SigmaPlot. Let's just rearrange my screen, and I will close this this what we've done here, and I have these data. Of course, I can tell you, or I'll show you now how you should enter the data. If you don't know it right from the start, you start with this quick start graph, scatter plot, and there, for example, you find error bars. And the starting point for such a plot I just showed you is a scatter plot with horizontal asymmetric error bars, because the error bars are not symmetric for odds ratios. And there you see the way how to enter your data. You have to need a y-axis, values for the y-axis, a value for the x-axis. That would be the odds ratio in my case. Then we have a value for the lower end of our error bar, because they are now asymmetric. So I have to tell the program, okay, what's the lower and what's the upper value. That's why we have 2 columns for this. X2 would be another set of data. So you just have these 4 columns, like I have here in my worksheet. I just labeled them. We can also put labels on the columns here, so you might know a little bit more about it. And we start with an create graph, scatter plot. This one here, horizontal asymmetric error bars. I have y and x pairs. No, so this way, y and many x. I select the y, that would be this one, label position, odds ratio is x, the error 1. And then this might be confusing, you need an error 2. I don't know why it's called x2 here in this case, but just select the upper value and you're good to go. And when you click on finish, we have this. And maybe you think, right, it doesn't look in any way like the graph we just saw. Yeah, it doesn't. We have to tweak a little bit around, and since we don't have so much time anymore, I will do it quicker. You might want to recap this in the when you have the recording of the session. First, I want to select the labels for my y-axis. Here we have numbers 0 to 10. That's not informative. In my data set, I have labeled them with red wine drinkers and so on. And I can use these labels here in my graph as well. Therefore, I have to go to major tick labels. And usually the type is numeric, so you have numbers here. But you can select a column from your worksheet. To use here, for example, I choose label. Yeah, okay, that's the first thing. But now they don't match anymore to my values here. So I have to adjust the tick's position as well. And then here under tick intervals, I can also select a column in my worksheet, and it would be labeled position in my case. And now you see, I have all the values, because now we have an x and y axis with 1, 2, 3, 4, 5, and so on. And it's represented with these numbers, 1, 2, 3, 4, 5, and these labels. So maybe you say, well, it's not the correct way, none, 1, 2, I want it the other way around, like in the chart we saw. Of course, we can do that as well. Just change the scaling. Click on scale and then say, okay, don't start with 0, start with 10, and the end is 0. And so we have it the other way around. Great, we are done here. Then, of course, I can address the lines again, because you know right now I don't like the lines. I don't want them there. I don't want the x-axis on the top. I don't want major ticks on the y-axis, so that is gone now. And of course, you can also address the error bars, that you might want to use a different color, or you want to use a different symbol or a smaller symbol, not 2.5 millimeters, maybe just 2, and maybe make it a diamond. Diamonds are nice. Yeah. In case for box plots, for this kind of plots, you would like to have a reference line, as you saw here, we have a reference line at 1. I can add it very easily here as well. Maybe you see, oh, I don't have a custom value, but just choose one. Just select mean, not this, not the horizontal direction. I want it in the vertical direction. But I don't want the mean of the values here. I want to change it. So just choose under calc, calculate is it, that you want to enter a constant value of your own choosing, and it's 1. Then of course you can select maybe a dotted line, and then we have this done as well. I will make this a little bit smaller. And one last thing, because now every label looks the same, but I want to maybe highlight beer cider drinkers and red wine drinkers to mark that these are categories, or that are these this is the section I'm in, and these are the subgroups. You can do so in your worksheet as well. In your worksheet, you are able to right-click every cell, and then you can say, if it is a text value, you can format it. For example, you can tell the program, okay, make this bold, and this one should be bold as well. Not bold in your worksheet, but bold in your graph. Very nice. Because if you select these values here, the labels, you will change every label. If you want to change the specific labels, then do so in the worksheet. That's very nice. This is something that is very, very hard to do in other programs, and that's one thing quite easy to do with SigmaPlot. Of course, you can get rid of this label here as well, and so on.
Okay, Sebastian, I'm sorry, I have to interrupt you there. We have another webinar starting in 1 minute. Thank you for the great presentation and demonstration of SigmaPlot 15. It's SigmaPlot 15 was released just a few weeks ago. So to all of you who are watching with a maintenance agreement or subscription, we have started sending out a new version. So, and if you are interested in an upgrade, just contact us, and we will of course send you an offer for this. Okay, thank you, Sebastian, again, and we will be seeing each other tomorrow. So have a nice day until then.